Welcome to The Explainer. Today we're going on a wild ride, from a mind-bending hypothetical disaster all the way to an incredible real-world story of survival. And it's all connected by one simple thing: the spin of our planet. Okay, so let's just dive right in with a question that sounds like it's straight out of a sci-fi movie, but has some very real, very physical answers. What if the ground beneath our feet just stopped?
The immediate result? Well, it wouldn't be some gentle halt. We're talking about a cataclysm on a planetary scale. Everything we know would be over in a single, incredibly violent moment.
To really get why, you have to wrap your head around just how fast we're already moving. Right now, if you're somewhere near the equator, the Earth is spinning at over 1,000 miles per hour. That's about 1,600 kilometers per hour. We don't feel it, right? Because everything, the air, the oceans, you and me, we're all moving right along with it.
But if the planet suddenly slammed on the brakes, the law of inertia would take over in the most brutal way you can imagine. Everything on the surface isn't actually bolted down, so it would just keep right on moving at that original incredible speed.
You know, one Reddit user captured this sensation perfectly. Because the planet halts and you don't, it would feel like being instantly launched forward at supersonic speeds. It's a violent acceleration, not a stop.
And of course, because it's the internet, another user summed it up even more succinctly. Everything not part of the planet's solid crust would be instantly flung eastward, a truly global yeet.
So let's imagine for a second that something or someone survives this initial event. What kind of world would they find? The answer is one that's almost completely unrecognizable.
And this just lays out the insane changes. See, the planet's spin creates a slight bulge around the equator. Without that spin, gravity would pull that bulge back, causing the oceans to literally rush toward the poles. You'd get two massive polar oceans and a new supercontinent around the equator. And our day? It would now last an entire year.
A year-long day means 6 months of unrelenting sunlight, followed by 6 months of absolute freezing darkness. The side facing the sun would be completely scorched, while the dark side would get so cold you could literally see carbon dioxide snow falling from the sky.
Now let's pivot from that terrifying thought experiment to a real place on Earth, where life already endures a similar, although thankfully less extreme, version of this very scenario.
While a year-long night is hypothetical, our planet's axial tilt already creates the polar night. This plunges the Arctic and Antarctic into months of complete darkness every single year. It's an extreme environment that life has already conquered.
So what's really interesting is how some of the planet's most fundamental life forms deal with this annual darkness. And the answer is found at the bottom of the Antarctic Sea.
Let's meet the heroes of our story, benthic diatoms. These single-celled algae are a huge deal. They form the base of the polar food web, and, get this, as a group, diatoms produce more oxygen than all the world's rainforests combined.
To test their limits, scientists did something remarkable. They took these diatoms and simulated an extreme 10-month-long polar night in the lab, way longer than a typical one, just to see what would happen.
And the results at a cellular level are just fascinating. On the left, you can see the diatom's internal solar panels, its chloroplasts, are all disorganized and degraded after 10 months of darkness. But on the right, after being re-exposed to light, they've started to rebuild and reorganize. It's incredible.
And this is amazing. Even after 10 months without any light, these diatoms weren't dead or even fully dormant. They immediately retained about 60% of their maximum photosynthetic capacity. They were just waiting, metabolically active, ready for the sun's return.
But here's the crucial point. While survival is immediate, bouncing back completely is another story. The data shows it takes these tiny powerhouses up to 5 months in the light to fully restore their photosynthetic machinery to peak efficiency.
So what does this microscopic survival story teach us? When we look back at our planetary catastrophe, a powerful theme emerges about life's relationship with its home.
The diatoms reveal this sophisticated strategy for enduring extreme darkness. They don't just shut down. They stay active, they cannibalize, and then rebuild their internal parts. And they rely on stored energy. Their slow recovery shows us that survival comes at a cost, a vulnerability that highlights the fragility of this resilience.
And this is the real takeaway. Whether we're imagining an apocalypse caused by the laws of motion or studying a real cell surviving the annual polar night, we see the same incredible theme. Life is profoundly adapted to the fundamental physics of our spinning world, finding ways to endure in even the harshest conditions.
It really leaves you wondering, doesn't it? This amazing capacity for survival is happening all around us on a microscopic scale every single year. It just makes you think about what other incredible stories of endurance are hidden in plain sight right here on our spinning planet.